Okay, so let's move on to something a little bit trickier. Now, well, actually, I'm sorry, this isn't trickier. It's something where we can think about things in a slightly different way. Now, this is a pattern, an expansion called a perfect square. And usually when we talk about perfect squares, we mean numbers like 16, for example, is a perfect square because it's equal to 4 squared. So it's 4 multiplied by itself. And when you look at these two expressions, they've both got the same binomial factor. So this is the same as x plus 1 squared. But we need to actually figure out what this is going to look like. So let's do the expansion. So go with the Crab clause again. And we're going to figure out what these evaluate to. Okay, so x times x, easy, x squared. X times 1, well that's nice and easy in this case, it's just plus 1x. Then plus 1 times x, again plus 1x. And then plus 1 times plus 1, well that's easy, that's just plus 1. So simplifying this, I can only simplify the x's and I get x squared plus 2x plus 1. Now at the moment you're not going to see a pattern here, but we're going to do the next one and figure out what the pattern is. But what I'd actually like you to do is to see if you can work the expansion out for yourself. So see if you can expand and simplify this. Pause the video for a moment and do that, and then start up again and I'll work through it. Okay, so hopefully you paused that and had a go. Now I'm going to work through this one. Now remembering crab clause or FOIL or some other technique to help us evaluate what we need to do here. So firstly, multiplying the first two terms, so x times x again is x squared. Then I've got x times negative 3. Now that's going to be negative 3x. Then I've got minus 3 times x again. So again, I've got another negative 3x. And then I've got negative 3 times negative 3. Now, this is going to give me plus 9 because I had two negative terms. Alright, so then let's simplify this a little bit. All I can simplify is the x's. So I get x squared minus 6x plus 9. Now, this is where you might start to see the pattern. So firstly, hopefully you got the expansion part right when you did it yourself. If not, have a look over the steps that I did and just see if you've made, if you can understand where you might have made any errors there. The pattern though is what we're really looking for when we're talking about perfect squares, because if we see this pattern, then it means we can expand stuff without really even needing to work it out. We just need to understand what each part does. So think about up here, we had x plus 1 times x plus 1. What we've ended up with is, so x squared plus 2x plus 1. Now, okay, can't really see a pattern there. Come over to the next one, we've got x squared minus 6x plus 9. Now the pattern becomes a bit more obvious because minus 6 is 2 times minus 3, and 9 is minus 3 squared. If we come over here, 2 is 2 times plus 1, and 1 is plus 1 squared. So it is the same pattern in either case. So what we're seeing is, if we've got a perfect square, so say we've got x plus a squared, then the pattern we get is x squared plus 2ax plus a squared. So whatever the a value is, and it can be a positive or a negative number, so for example, if we did x minus 5, like this one here, square that, the pattern is x squared plus 2 times negative 5x plus negative 5 squared, and that is just x squared minus 10x plus 25. So that's the perfect square pattern. Now the next one, Here we are with the next pattern. So this is called the difference of two squares, and you'll see why that name makes sense shortly. Now, the only real difference between what we're looking at here and what we saw previously is that rather than having x plus 1 multiplied by x plus 1, we've got a situation where we've got x minus 1 multiplied by x plus 1. Now, it doesn't matter which order you write these in, because remember, we can always swap the order around. So x minus 3 times x plus 3 is exactly the same as x plus 3 multiplied by x minus 3. So it doesn't really matter what we do there. But what we want to do is expand and see what happens. So let's do that. Crab claws again. And so what do we got? X squared. Now x times minus 1 is going to be minus 1x. But then plus 1 times x is going to be plus 1x. And then plus 1 minus 1 is going to be negative 1. Okay, so if we simplify this, well, our x terms cancel out. So what we're left with is x squared minus 1. So it looks a bit different to our previous example. Let's come over here and have a look at this one, see what happens. Now, it's a really similar example. X times x is x squared. Now, minus 3 times x, so minus 3x. Then we've got x, sorry, I've expanded that all wrong. That should have been plus 3x, my apologies. Then, and that's what you get when you don't do crab claws, of course. So then minus 3 times x, and then minus 3 times plus 3 is in fact minus 9. So we cancel our x's in the middle, we're left with x squared minus 9. Now, remember the name, the difference of two squares? Well, x squared is a square, and the numbers, so 1 and 9 are both perfect squares. So this is the difference of two squares. So what's the pattern here? The pattern is that it is, so if we've got x minus, or sort of plus or minus a particular number here, the pattern is we're always getting x squared, so our first term squared, minus our second term squared. So that always happens in the difference of two squares. So say we have x plus a, x minus a, or our answer that we're always going to get is going to be x squared minus a squared. So it doesn't matter what numbers we put in here at all. So let's go x, I don't know, plus 11. Actually, I'm going to make this a little bit trickier for you. I'm going to put in 2x plus 11 and 2x minus 11. Now, the only tricky thing here is we've got to remember that when we're squaring everything in our first term, we're actually going to have to square this whole thing, because what we would have been doing is multiplying 2x times 2x. So it's not going to be 2x squared. Our answer, in fact, is going to be 4x squared. And then minus a squared, well, that's just going to be minus 11 squared, which is just minus 121. So this is the difference of two squares. Now, being able to expand and recognize these patterns is very helpful. Now, it doesn't actually matter though if you can't do that. You can always expand using FOIL or crab claws, and you'll be able to get the right answer. But if you get to the situation where you see something that has, say, a perfect square pattern or a difference of two squares pattern, well, that means you don't really need to use FOIL. So, you know, if you see something that is x plus 7 multiplied by x minus 7, well, I can recognize that as a difference of two squares pattern, and I don't actually need to do any crab claws, any FOIL, or anything like that at all. I just know that it's going to be x squared minus 49.